This is the ROS Developers Podcast, episode 95.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct. And today I would like to dedicate the episode of today to all those people there that are teaching robotics worldwide. And of course, they are using ROS for that. So in case that you are having even simple basic classes about robotics, or you are going to more complex concepts about robots, and you are using also ROS in all those classes, this episode is dedicated to you. And today we have another episode where we are going to talk actually to one teacher that is teaching robotics, but at a very different place. Actually, is on the United States Air Force teaching about robotics. But before going into that, let me tell you about the ROS Developers Day. That's the conference that we have been preparing, and it's going to be delivered in the next month. So let me show you here on the screen. Where is this? I thought I don't get this. I'm trying to capture here the... Okay, so here it is. There it is. Then this conference, it's about the ROS Developers Conference, where we are going to be listening to several speakers that are ROS experts, and they are going to teach us how to do different things in ROS, and actually quite specialized things in ROS. So this is the fourth year that we are organizing this conference, and you can see about the speakers that we have a very, very good set of speakers. For example, Steve Beyer, who is one of the creators of the Navigation 2 stack for ROS 2, or Steve Beyer from Canonical, the company behind Ubuntu, and he's going to talk about security in ROS. Or Ben Magyar, that he's one of the main developers of the ROS control packages, and he's going to be talking about this, about ROS control in ROS 1 and ROS 2. And many others. Yukata Kondo, the creator of the first ROS 2 book in the world. Jorge Nicho, talking about applications for industrial robots, and many, many other people. Okay, so you can check here on the webpage. I will put a link below the description, and you can see the agenda. Which subjects are we going to talk? But the most important thing, let me go up, is that you are going to be practicing with the speakers. So you are not going to be watching a video and listening to this guy talking about a very interesting subject. No, they are going to be teaching you how to do those things, and you are going to be practicing at the same time. So you're going to launch those programs. You are going to make the robot grasp the element or detect the object or whatever it is the subject about. You can have a look at the agenda, and then you will see the different subjects that we are going to cover, but they are going to be covered by those impressive speakers, panel of speakers. Then I would like to thank now to the sponsors, especially Usernet is the keystone sponsor of the conference, and then the other sponsors, Robotnik Company, Usarion Company, and Power Robotics. In case that you are a company listening to this and would like to be a sponsor, you are still in time, and then just contact us. Okay, so have a look at the website and decide, of course, to get a ticket. Let me remind you that also for the tickets, we have a special gift for all the attendants. For example, we have a 6 months Usernet package for 100 devices that is going to be delivered to everyone, every attendant to the conference. And that has a value of hundreds of dollars and is delivered by Usernet to all the attendants. And other surprises that we have. Check the website and then you will have more details. Okay, great. Then let's go back again to our presentation, our talk. Yes, and now it's time that we go straight to our subject of today. Then for that, let me introduce Steve Beyer. Steve is an embedded systems engineer and roboticist that is a member of the United States Air Force and is developing the United States Air Force digital communications infrastructure in the Middle East. Well, he was doing this. And more recently, he changed his role to senior instructor of embedded systems and robotics at the United States Air Force Academy. So let's talk with him about teaching robotics at the U.S. Air Force. Welcome to the podcast, Steve.
Hey, thanks, Ricardo. Thanks for having me.
My pleasure, my pleasure. So I remember that I was seeing some of your comments on LinkedIn about one podcast episode, and then I saw that you were teaching about robotics and ROS, and you were working at the United States. Well, you are enrolled at the United States Air Force, and I thought, what a super cool subject to talk about, and that's why I contact you.
Yeah, definitely. Let me just do a quick disclaimer real quick. So the views expressed during this interview are mine and do not reflect the official policy or position of the Department of Defense, United States government, United States Air Force, or the United States Air Force Academy. So we have that in the clear. So this is all my views, not the military's.
Great.
So yeah, I saw that post on your podcast. I've listened to your podcast. That was actually one of my favorite posts because you were doing deep work at the time. And I'm a huge deep work fan. I love Cal Newport and deep work. And so that's really what kind of brought me into listening to the ROS Developers podcast and then to the construct. And then I've integrated some of that into my teaching, but we'll get into all of that.
Okay, I didn't know that all those things about deep work, and I had no idea that you get into know us because of the deep work work that I have been posting online. Okay, that's a surprise. And then you apply this into your daily life.
Yeah. So I do two 2-hour deep work sessions a day.
Wow.
So I work. It's a little harder when you're teaching, right? Because you have students coming in, they want to ask questions. But in the summer is a great time because you're not interrupted. So I do 2 deep work sessions a day. And I always say to myself, if I can't figure out something within 3 deep work sessions, it's time to find an expert because I'm not going to figure it out.
Okay, it's a good heuristics for finding solutions to problems. Just for the audience that are out there, maybe they don't know what are we talking about deep work, because it's nothing related to ROS. It's just about working in a very focused way and without any distractions, and this allow us to get the best of us and to crack important problems. So your heuristics makes a lot of sense, because if you have put in all your essence, all your person into the problem for several hours and then you don't get the answer, then maybe look somewhere else. That's very good heuristics.
Well, you said it doesn't relate to ROS, but what I found, and Cal Newport talks about in his book, 2 core abilities deep work helps with: the ability to quickly master hard things and the ability to produce at an elite level in terms of quality and speed. And I found with ROS, especially with how complex it can get, you need to be able to master hard things quickly, because you'll just get lost and you'll get behind the schedule. And so deep work and ROS go hand in hand to me. Because of how hard some of the concepts are. You can't spend a month trying to figure out how to integrate, all the navigation. You have to do it in a quick manner so that you can move to the next step. And I think for me, deep work is the only way I've been able to do that because of how complex the problems are.
Wow, awesome exposition. Wow. You have my vote. So completely agree with you. And so Awesome. So for the people out there, if you don't know what is deep work, just search on the on Google, and then you will get the book of Cal Newport. Buy it, apply it, and so on. And just in case that you want to apply, you don't know how. I wrote a book. My English in that book is not very good, but the plan for training is very good. So you can also find it on Amazon as with a complete plan. That is the one that we use at the Construct for training the people of the team. Okay, great. Okay, then let's go back to the subject of the podcast, which is about how did you start it with robotics?
Yeah, so my robotics started during my bachelor's degree at University of Portland. There was an instructor there, a professor who took me under her wing, Dr. Tanya Crenshaw, and she was doing research, which for an undergraduate level, so I was a third year undergraduate, doing research was not very common. So not very many students were doing research. She was developing an iRobot Roomba, adding an embedded computer. At the time, it was called a Gumsticks. It was before Raspberry Pis existed. It was very difficult, but we figured it out. We created a test bed that allow undergraduate cyber physical system research. And so no ROS at the time, but if we had ROS, it would have been a lot easier. But we were able to get a publication out of that, which was my first experience with robotics and doing publications. Got to go speak at a conference in DC, and I can send you that paper if you're interested. But so that was the first time. And when I had that experience, I knew it was basically what I would say is the best experience of my undergraduate degree. And that's what I wanted to share for other students down the road. So I knew at that time I wanted to teach eventually and to provide students at the undergraduate, so the bachelor's degree level, an opportunity to do research because it was such a cool engineering opportunity for me. And so that's kind of where I had that first kind of inclination to do robotics research. I was in the military, so the way it kind of works sometimes is you go to a normal university, but then part-time you do military training. And then when you graduate, you automatically go into the military. So when I graduated, I joined the United States Air Force. And unfortunately, I spent the next 6 years not touching robots. So that was sad, but you kind of have to just go and do what the Air Force tells you. And so as an engineer in the Air Force, I don't fly planes, but what I do is engineers have 3 jobs in the Air Force. They either buy systems for the Air Force, they can develop systems for the Air Force, or they can test systems. And so what I did was test Air Force systems. So it was a really cool engineering project. Boeing, Lockheed Martin makes something for the Air Force. We test it to make sure that it's going to work for our forces out in the Middle East. And then it goes, if it passes the tests, we send it out to the Middle East, and then we get to use that system. And so that's kind of what engineering in the Air Force looks like. And so that's kind of why I didn't get to touch robots for 6 years, unfortunately.
Okay. But also sounds like a funny work because you are testing very different technologies that also they are supposed to work. So most of them, they should work. And then you are having the fun part is when everything works and then you are doing the nice things and you have new devices. Okay.
Yeah. It was testing. The test world is a lot of fun because you get to see real systems. You get to touch them, you get to test them, you get to play with them, and make sure that they work. So I really enjoyed it.
Okay. And then so you clarified my next question, which was about so how did you get into the Air Force? But as you mentioned, you already were doing your graduated university time, and then after finish this, then you go straight into the military missions that they assign to you or position that they assign to you, right?
Yep, exactly.
Okay, and then so for the next question, let me see. You were doing this test, and then you were away from the robot. So how did you transition into the position that you are now, that you are teaching robotics, and actually you have developed some robots also for learning, and we'll talk later. So how did you transition from that position to the other?
Yeah, so after about 4 years of testing systems, I applied for a competitive program called, it's basically they send you to go get your master's degree. And then after that, you go and get the opportunity to teach at the Air Force Academy. So I spent 2 years getting my master's degree in computer engineering. I focused in cybersecurity of Internet of Things. And so that's where I did my master's. And then as I graduated from my master's program, I then went directly to go teach at the Air Force Academy in Colorado Springs, Colorado.
And were you teaching about your master's degree subject, or at that point already switched to teaching robotics?
So at that point, I came in to the Air Force Academy as a instructor of electrical and computer engineering. So very general topics. I was teaching to the students there. And then as I spent the first year, I started getting more interested in robotics.
Again, so you were feeling the call.
Yes, exactly. So when I arrived at the Air Force Academy, and let me just talk a little bit about the Air Force Academy.
Sure.
So it's an undergraduate degree program, so very similar to every other bachelor's degree program, except these students are full-time military members. So this is a military academy, and so they're taking classes just like every bachelor's. It's actually a liberal arts college.
One question before you
Yes.
continue. So that is different from the one that you studied at the beginning,
Yes,
right? The
exactly.
other one was normal university.
Exactly.
And then when you finish, you have to go straight into the military service. But in this case, it's a specific academy inside the military, right?
Exactly. So I went to university with people who were not in the military.
Yeah.
So they went to go work at Intel. They went to work at Lockheed Martin or any other engineering school, engineering company. But at the Air Force Academy, every student goes to the Air Force.
Okay.
And
Yeah, go ahead.
so it's a liberal arts college. We have, English, we have, chemistry, all of those normal classes. But then at the same time, they're doing military training. They wear their uniform every day. And then once they graduate, they go and join the Air Force.
Okay. And then, I don't see why do you have those two different programs in order to get people in the military? So if the end point is to get people that is qualified as engineers or any other subject, well, let's say in your case engineers and of a certain type, and then military people of the army, of the military that are qualified as engineers. So why those two different paths, like the one that you took and the one that you are teaching now?
Yeah, exactly. So they are very different, and the reason they're different is for diversity. So me coming from a normal university, I have a lot different experiences. I got to work. I worked part-time at Daimler Trucks doing research for computer engineering. I was able to, the instructors are all civilian instructors. So it gives me a lot different experience. So my background is a lot different. So when I do go on active duty, I can carry that background with me and solve problems from a different perspective. Whereas at the Air Force Academy, the education is very top level, but they just have a different experience.
Yes.
So it's all very military. I'm a military person teaching military people. And so it's a very different experience. And so it just helps us to provide diversity to our active duty military.
Diversity of ideas makes perfect sense. And then when you are in the problems, in front of the problems, then you can have all those different ideas in order to attack the problem. And in some cases, it will be better to be more, let's say, I don't know, okay, but let's say more strict or more disciplined way as the military. That's how I see the military. And the other way is more like freestyle ideas and on the other way. I did myself the military service here in Spain, and then I'm basing this based on my experience. I understand it's not the same because you are professional, and it's your profession. So, but somehow based on the discipline, right? Is the military?
Yeah, exactly. So that's a great way to think about it. It's just very different backgrounds. Plus, we need a lot more people than our military academy can get us.
Generate.
So yeah.
Okay.
Yep.
Okay, makes sense. Then
So,
then a present. So what do you do? Are you teaching? Yeah.
So when I got to the Air Force Academy, so now that we have a little bit more background, so one of the things I noticed, and I got there at the same time that the department head for the electrical and computer engineering department was changing. So we got a brand new department head. I just arrived, and we both sat down and we said, what are our goals for our department? And one of the issues was the number of electrical and computer engineering graduates, so a number of people graduating with a electrical engineering or computer engineering degree, was declining. So in 2010, there was 28 graduates out of our department. 2020, there was only 15. And so that decline was kind of worrying us because the field of electrical and computer engineering is very needed in the Air Force.
Yes.
And it's all these different technologies are growing. We need those experts. And so we were getting kind of worried because people were not in our degree program. So we talked and we figured we came up with two goals. First, we wanted to increase recruitment to our major. And second, we want to spark interest in robotics because we were both very interested in robotics.
Okay.
And so the way I accomplished that and the way I attacked that was first, we modernized a lot of our laboratories. So we got rid of all of the old oscilloscopes. We got brand new. I don't know if you ever heard of Liquid Instruments. They have something called the Moku Lab. It's this iPad that allows you to use an oscilloscope, a function generator, all kinds of different tools, but it's a very modern system.
Okay.
Then I took the classes that I was teaching and it increased focus on hands-on experiential learning. So basically my idea was I want to get people excited about ECE or electrical and computer engineering. And so the best way to do that, in my opinion, is to get your hands on things like robots. So that was the next thing I did. I added 2 courses to the major, which I'll talk about here in a minute. And all of those things combined are what helped me to win the Innovative Educator of the Year award for our university, which I was super excited about not because of the award, but because of what it meant. It meant that we were increasing the innovation in our department, and I was really excited about that. And so the primary way I created innovation was using something called what I called the USAFA bot.
Okay. USAFA bot. Okay, so, that's it.
United States Air Force Academy robot, USAFA bot.
Very good.
This is the first robot I got to build from scratch. And I actually loved it so much that I created a whole course around it.
Okay.
And we call that course the Introduction to Electrical and Computer Engineering. So why did I create a course about this? Well, I wanted students who were not declared, so they had no major yet, to come into our department and do something fun that also allowed them to see what kind of things they could do in our department. So students build this from the ground up. They get their own.
Each one.
Yep.
Awesome.
Each student gets to build their own. Everything is 3D printed. So you got 3D printed wheels, 3D printed layers. So we get to teach the students how to 3D print. There is a printed circuit board that I designed in here that is basically the motor controller, kind of integrates the DC motors. It has a power distribution system. But each student gets to solder and build their own printed circuit board.
Wow.
So they get all the resistors, all the transistors, they solder them all together. We test them, make sure they work. Once they work, then they build the rest of the robot and they start driving it around.
Wow.
It has an Arduino Uno that they use programming Arduino C and then 2 distance sensor or 3 distance sensors and then line sensors.
On the
and
back.
then a battery.
At the bottom.
And so, rechargeable battery.
Uh-huh.
So students will basically learn fundamental ECE, electrical and computer engineering topics, so programming, soldering, circuit analysis, power budget, but they get to build it from the ground up. So why I like this versus other robotic systems that are out there? Well, first off, the student gets to see every single different step of building it. So they get a 3D printed. They could change how it looks. We teach them how to do the CAD design. The other reasons I like it, because if something breaks, I know exactly how to fix it. I designed the whole thing, and all the source code and everything's open source. So this is what I'm publishing. I'm publishing a
A
paper about it
paper. Yeah.
this summer, and so everything will be available. So any instructor can build it, and you don't have to worry about it being discontinued. It will always be there. You can always get the parts. And so that's why I really enjoyed it. And the students really loved building it. And each one of them gets their own. They get to keep it forever. So even if they don't declare, they get to keep it, but they just get to enjoy it. So right now, not ROS enabled. I am working with 2 students to get it ROS enabled this fall.
Okay.
So we're going to put a Raspberry Pi on top.
On top.
We're going to add an IMU or orientation sensor so that it can drive around.
Uh-huh.
And then, so yeah, that's one of the first things I did in the department was how do you make ECE fun? And so that students will come in and they want to stay.
Yes.
And, hands-on learning and robotics were the 2 ways I felt like to do that.
Exactly. And your example is awesome that you are doing the students, to do all those things from nothing to a complete robot, including all the steps, because, for example, in our company, in the construct, we concentrate more on the software part. Mm-hmm. Okay, so we teach some things about electronics and building robots and so on, but that's the minimum part. Basically, we concentrate on building the software. But in that example that you mentioned, the USAF bot, you are doing all the parts that are included into a robot. First is the hardware. But the hardware, I mean the wheels, the chassis, all those different layers that are physical, that they need to be designed, and then they need to be built, and they have to work. It looks like, it's just a piece of plastic. Yeah, but it has to be made in the proper way so that then the wheels, they can turn and they don't get trapped into one of the parts of the other plastic or things. So that's the first thing. Then second thing is the electronics. Mm-hmm. That's another thing. It's the electronics, the control board. So you are also including the printed board that they have to do to print themselves, right? Okay. Go.
It's hard to see. I don't
yes.
want to take it apart because it is a pain to put back together.
No problem. No problem. We'll put a link in the podcast show notes about to your page where I have seen this robot, and also the mention to your paper that is going to be published and all the parts that are there.
Yep, and it's all open source. So I have everything from the CAD models to the design for the printed circuit board. So everything can be redesigned. It can be or you can add it to your own university if someone's interested. And what I really enjoy about it is you can get a student who's never touched electronics, never touched circuits, and then get them to the point where, hey, I'm driving this in a maze and it's following walls and going through a maze in about 40 hours is how long they get to work on it.
But 40 hours is the amount of time that they get to understand how all those parts. 40 hours, okay, that's quite fast, I would say.
So it's a semester. So each semester is 40 lessons, and each lesson is about 53 minutes.
Okay.
And so, it takes them a long time to build it.
Yes.
Once they build it, they pretty much get going.
And how many have you built already? how many students they have followed this path?
We've had about 85 students.
Wow.
Take the course. Yeah, so like I said, we had 15 graduates in 2020. Since then, we've had about 30 to 35 students per year, So since I've tried to increase, myself and my department head. My department head is really Colonel Brian Neff. He's really worked to make our department the best in the Air Force. And so between us and just working to get students into our department. So yeah, so this is the first robot they get to play with, but it's not the last robot they get to play with.
So what's the last one? What's the next one?
Well,
let's say.
Let's go with the next one.
Next one, exactly.
So so once I built that one, I got the robotics bug. So all of my courses, I had to figure out how to get robots.
Okay.
So this one I did not design.
Uh-huh.
I don't know if you've heard of it. It's called the Texas Instruments Robotics System Learning Kit.
I saw in your at your web page, but I didn't know before.
So I teach it's embedded computer systems. It's a 300 level class. So a third year student usually would take it. So basically, this is provided by Texas Instruments, and they actually provide a whole curriculum for embedded systems that is in partner with, I believe it's the University of Texas. I'd have to check that to be sure. But they developed curriculum to take students through 18 laboratories. So they build this robot. They do, again, very similar. So $100, a little less than $100. I think this comes out to about $60 to build. This one's a little over $150, but much more advanced. It has encoders. It has the MSP 432 Texas Instruments embedded microcontroller. Yep. And so it's very, very much more advanced than this little Arduino, but very similar labs. So I kind of try to make it so that the students will transition very well. So they learn everything from analog to digital conversion. They're doing analysis of the line sensors and how they work. They're doing all the embedded computer systems curriculum that you would expect in a normal class, but all based on this robot.
And it's another way. I mean, it's a way of learning about embedded systems applied into a robot, and you have so you have this curriculum that in this case is not built by you but is by Texas Instrument. But
so I basically adapt their curriculum. So I made some videos, so the students watch videos outside of class to learn the topics, and then in class is all laboratories. So there's 18 different laboratories. So they integrate the IR distance sensors, the bump sensors. They're doing interrupts. They're doing all kinds of different embedded systems processes, but in incremental steps to get this thing to drive. So they're working with the tachometers, they're working with the pulse width modulation, and so all the different steps to get this guy to drive. They're working with the LCD, so they're doing SPI and all those different technologies, and so, but again, all based in a robot.
Great. Yeah. So you are repeating all the time that in order to learn robotics, then you have to be doing, not just watching videos or listening to somebody or doing mathematical things, but build the thing and make it work. Those things. Yeah.
Yeah, and you can on my website, which I can send you the link. I think I did already.
Yes, I got it.
I talk about this, and I link to Texas Instruments curriculum. So again, it's very easy, off the shelf. You can get this curriculum. You can start working on it at your university. I've really enjoyed it. The students love the hands-on method. And again, the class ends in a maze competition. So basically, who can get through the maze the fastest? There's different levels. So line following level, a bump level, and then wall following. And so they get to go through the different levels and compete. And it just makes it a lot more fun to implement all you learn over a whole course when you get to have a nice little robot to do it.
Yes, that's right. And so you mentioned that you have published in your web all the links to the curriculum and the robot pieces and so on. I will put a link in the show notes so all the listeners can find it. But what about your curriculum for your robot? Is it also available? So you mentioned that.
So once the paper publishes this summer, it'll be available then.
Okay.
once the paper gets out there and out to public release, then I'll be able to publish all the material that goes along with it. So
Okay.
this robot, yeah, everything you'll have basically everything you need to build and teach based on this robot.
Okay, okay. So the signs of that, they are already in your website, but the teaching material associated to it is not yet until summer when you publish the paper.
Correct.
Okay, perfect. Great, great. But that about that robot based on Texas Instrument is not
Yep.
the last one. And
Nope,
it's not the
there's
last one.
one more.
There is one more. Okay, okay.
So
We are
this
getting
is where ROS comes in.
yeah,
Finally,
exactly.
ROS.
So everybody is nervous about that. So what? But where is Ross? Where is Ross? The ROS
So-
Developers podcast.
The last few months, what I've been basically working on my personal time, so outside of my military time, because I've been teaching all semester and it's a lot of work. So I took Texas Instruments, so Robotics System Learning Kit, and ROSified it.
Oh, okay.
So we got the same robot down here. So and this is one of the reasons I love this concept is students learn everything about this thing. So how do I integrate the encoders, the pulse width modulation from the ground up? And now
That's
they
wait
get to
a second. Wait a second. Just to clarify for the podcast for the people that is not watching the images, so they are listening. So you have shown the Texas Instrument robot, and then you mentioned that by learning how to build that one, they are learning the basics of electronics for robotics, which is about how to get data from the encoders and how to send signals to the motors and make them move and so on. But this is the basic of a robot. But then on top of that, you want to do something else.
So then on top of that, I built basically ROSified their robot by 3D printing a layer-based, so allows you to add on sensors. We have a Raspberry Pi 3B Plus up here, which is going to be the brain of the system. This version, so basically I allow students or research efforts to kind of integrate however they need this robot. So this one has a RP LiDAR, A1 LiDAR on it for obstacle avoidance or mapping rooms. And so what I like about it is the base of the robot is something the students have seen before. They actually programmed everything in that robot.
Exactly.
But now they get to use it at a much higher level, application level, by integrating ROS and the Raspberry Pi. So the Raspberry Pi, what it's going to do is just send the linear and angular velocities to the Texas Instruments robot to drive it.
Okay,
And
wait a second. Wait a second. Let me interrupt you. Sorry. And then why do you need the Raspberry Pi?
So the Raspberry Pi allows for multiple upgrades from the MSP432 embedded system. The Raspberry Pi gives us network connectivity. The Raspberry Pi has a much higher rate processor and memory and an operating system that allow the students to go in there and look at, open up RViz if they need to, or interact with all the Python code. So the MSP432 is all C programming, whereas the Raspberry Pi allows for Python or C++, normal.
Actually, it's a full computer. It's a full.
Exactly.
And then one question: you are not replacing the previous control board on the Texas Instrument. You are adding this on top.
Exactly. So the basically everything they've done in the embedded systems course is still available to them.
Exactly.
And the MSP432 is what drives the robot. There's a PI controller on the MSP432 that drives the motors at a given rate that from the command vel topic. So that is sent over serial to the MSP432. It allows the linear and angular velocities then to drive the robot. And then the Raspberry Pi just allows us to, like we said before, get to that next higher level. But you can throw in artificial intelligence, computer vision, You can throw in teaming, machine learning, all on the Raspberry Pi versus the MSP 432 is a lot more limited.
Yes.
And Raspberry Pi gives you ROS capabilities.
Exactly. So it's there where you install ROS.
Exactly.
Because ROS needs to, just to clarify for some people of the audience, many people of the audience already know about that, but so let's provide this information also for the people that doesn't know. Then the ROS you cannot install straight into the microcontroller board that the Texas Instrument was using as controlling. So you need some computer capabilities in order to install ROS. There are some versions for installing. Do you know about micro ROS?
I do, yes.
Have you done any experiment with that already?
I've looked at it, and I have not, just because the community out there for the Raspberry Pi and ROS is so strong.
Yeah.
And it's a lot easier for students to continue at that level.
Yeah.
So as a researcher, I think micro ROS would be a lot more useful. But for a student at this level, I think getting them a computer that they can actually look at and interact with.
Yeah.
But so students first learn about this ROSified robot in Fundamentals of Robotics Research. So basically, this is our version of the construct. So they learn Python coding, they learn Linux operating system, and then they learn how to do ROS, all based on the ROSified Texas Instruments RSLK. And so they go through, we teach them Python by interacting with the robot, Linux by, interacting with the robot. They integrate an IMU and LiDAR, and then they do basically enable this guy to be a Roomba, kind of drive around and not run into things.
Yeah.
Is the goal.
Yes.
But I enjoy, what I love most about the construct is just how everything's integrated very easily. So I can see Python, Linux, I have the simulation, but to get the students the hands-on experience with the real robot, each student gets one of these to mess around with and hopefully not break. That experience really makes the concepts more concrete.
Yes, that's definitely agree with you. So the optimal experience for learning robotics is exactly that. So you build your own robot and then you practice all the concepts about robotics, about ROS in English, right? In a robot. So that's the if you can do that, then you are providing the best learning experience to your students. Great.
So this is the Raspberry Pi has Ubuntu 20 LTS. It uses ROS Noetic, so it has all the latest software on it. This next semester, I'm going to be upgrading to a Raspberry Pi 4 with ROS 2. That's my goal, is to upgrade it to the next level so that we can use it for more real-time applications and stuff like that. So that's kind of what I will be working on in the next couple months.
Great, awesome. And then in that case, also every student is getting one of those. So they are building each student. Wow, that's awesome. Yes. I mean, that's nothing else. And just by curiosity, how did you manage that during the pandemic?
During the pandemic, so when they were all remote, what I actually ended up doing was boxing them all up and mailing them to them. So I mailed out about 20 of these robots to students.
Wow!
And then we did everything remotely. So they built them. They were all running around their houses, trying not to run into the dogs. It was actually a lot of fun. Because all these students are remote, so they're learning everything on cameras, and they don't get to play with anything. They don't have any experience. So I mailed them all these robots, and they got to mess with them and have them in their houses. It was actually somewhat painful because, setting up a Raspberry Pi, if you've never done it before, is difficult. So I had to teach them how to, you have to connect this to your monitor like it's a computer, and then connect to the Wi-Fi so you can access it, through SSH, and their brains are exploding. because they don't know how to spell Linux yet, and so it was a challenge, but the it was rewarding. The students who made it through those classes remotely were they're some of our top students now because they had to persevere through that.
Exactly, exactly. By the way, do you know that we have a Linux, just for the next students, a Linux course, which is free, completely free, and it's online, just in case that.
Yeah, that might be because I am trying to redesign that portion. So I'd have to. I think I took it last summer, so I'll have to look at it again. Um,
Okay.
so the other thing about just before we move on about the Rossify TI bot is we use this through a lot of our research in our department as well.
Mm-hmm.
So, for example, one of our students was using uh, sorry, let me switch that up.
No problem.
Um,
I also I also get without any words when I'm looking to the question, so no problem. That's just a conversation. Yes.
yeah. So one of my favorite projects we did. Let me just grab the last robot.
Okay, that's the last one. Okay.
So this one, I don't know if you've ever worked with Bitcraze or Crazyfly.
No.
So Bitcraze is a company that develops micro drones, so small drones. So called a Crazyfly. Uh, they also developed something called the loco positioning system, which is an indoor GPS. So it allows you to do positioning indoors based off of X, Y, Z coordinates system. So what we were able to do is add that to our ground robot so that the ground robot actually had basic, GPS coordinates of where it was in space indoors. And so it allowed us to fly micro drones indoors and also a bigger drone indoors that was able to do computer vision and find a target. And then the robot would be able to autonomously drive to that target. So it allows you to mess around with computer vision, navigation, and again, it's just based off that same robot that we developed, or I developed to upgrade up to ROS. So indoor localization using something called a Bitcraze Roadrunner and loco positioning system.
Okay, I didn't know about that.
Yeah, so there's a lot of universities working on different, swarming or teaming concepts. So teaming is where we were looking at. How do you, if you have a drone flying and it sees a target, can it autonomously pass that information to a ground robot that can then drive to that? And you can tell the somewhat military application for that as well.
Exactly, because you can find the target and then send the robot to capture that whatever it is. I mean, I'm saying capturing, but it can see to send. Send the water to somebody who is trapped or for the rescue. Exactly. Okay.
So what I want to point out is the modularity of the system. So since we 3D print, the layers of it, you can change it up however you want. You can add whatever sensors. You can do whatever you want. And so this robot is completely Rossified. It has Gazebo, RViz, simulation. It also uses the navigation stack to go and drive and navigate. So I'm going to, my department head and I are going to try to present this at ROSCON this year.
No way.
Talk about it.
Oh, okay. Are you going to attend?
That's the plan.
Okay, so then we'll meet there.
Yeah, that'd be awesome.
wait a second. Don't leave that robot so fast, because a couple of questions. So for the audience that cannot see the robot, so we can see that here on the image is the same Texas Instrument robot with a different printed chassis.
Exactly.
And that's the modularity that you were mentioning. That allows for different experiments. So in the previous one, it has a chassis that allows it to contain the LiDAR in a convenient way. In this case, you have modified something for some reasons that I don't know. Yeah, now we
Basically,
can see.
I had to modify it to get the way the loco positioning system works is you put all of these nodes throughout your test laboratory, and those nodes then send signals to the ground robot,
Mm.
and then based off the offset of those signals, it can know where it is in space. I just had to move that up high enough so that there was no interference with the Raspberry
Other,
Pi or other components on the system.
uh-huh.
And so, yeah, modularity is key. We have about 6 different research efforts using this robot, and each one looks a little different. So it's a lot of fun to see them all driving around, doing different things, and all kind of different colors and printed however you want to print it.
And one question about the positioning system that I
Yeah.
didn't know about. So it's actually GPS data that they are using, or is
It's not GPS.
fake?
It's just it's just fake localization. It gives you positioning data indoors. So that's the key. Is obviously it's really hard to get GPS inside
Yeah.
because of interference. So how do you simulate GPS? So it's just a positioning system, very similar to maybe the Qualisys video system or any of those other indoor positioning systems. This one just allows you to do it comes all built kind of together. So you have drones, you have ground units, and all kinds of different things you can integrate together to do research on without having to go outside. It snows a lot here, so we don't get to go outside very often.
Okay. So that's the reason. It's so what you would expect when you apply this into reality that we mentioned before, a real case scenario when there is a drone that goes to that place,
Yep.
is that this drone will have access to GPS in the outside.
Yeah, and that's the power of ROS right there. Is everything that I design inside with the different ROS nodes or incremental approaches. So the GPS is only one node or the positioning inside. So when I take this outside, I don't have to change anything else in my design. I don't actually have to change anything in my design other than where am I getting those positioning
The
data
data.
from? And that's the power of ROS, right? You don't
Yeah.
have to redesign the whole system. I can just change out the sensor. So now instead of using the loco positioning system, I'm using a GPS receiver. Everything else stays the same, and it allows me to not have to redesign the whole system.
Okay, great, perfect. Then super interesting. You mentioned a lot, a lot of the questions that I already have, but I think that you went through them. So now it's a little bit difficult to understand. Well, let me ask you one thing. You mentioned about the Gazebo simulation. Are you using Gazebo with your, robot simulations often with your students?
Yes. So one of the research projects we had were basically take 25 of these little robots that I designed and type in letters. So our department is DFEC, and then have all 25 of those robots go and create those letters. So we started that off with Gazebo, doing all the algorithms in Gazebo to simulate it. And I think if anyone's interested, you can look at my website to see that simulation. And then we actually use the indoor positioning system to do it in real life afterwards. And so it worked in real life. It didn't work as well, but it still worked.
That's normal.
All the algorithms were tested in simulation in Gazebo first, and then we did it in real life to see it. And you can see in my video on the website, I show portions of the real life, and then Gazebo, and then real life, and then Gazebo, and it's really cool.
Yes. Okay. Yeah, there will be a link in the show notes to that too. Okay, so for the audience to know. Okay. Okay. So, can I ask you so those robots you are doing all this because first you want to teach about robotics, but also because you think that robotics is going to be very useful for the military.
Yeah. So what I love about ROS and robotics in general is the incremental approach and how it teaches students and future Air Force officers how to deconstruct a problem to its smaller parts. And then you have to attack each of those smaller problems. So not only is that applicable in robotics, that's applicable in military operations and leadership positions where you have to look at something very complex and then break it down into its smaller problems. So we try to teach students these problem-solving techniques, and I think the best way to do it is through robotics. But
Ah.
also robotics. I mean, if you think about a jet is, yeah, there's aeronautical engineering, there's flight, but that's all been kind of figured out. What really it is, it's a flying robot, and everything else kind of coming forward and going forward in technology is going to be how do we integrate these robotic systems? How do we integrate the different sensors? And that's where we need these students to really be thinking is how do I look at everything kind of like, I mean, it's a flying robot. So how do I
Mhm.
solve this problem? And so really what I love about robotics is it teaches not only engineering, but also teaches real life problem solving skills
Solving.
that they'll use as leaders in the Air Force.
Uh-huh. Okay. Wow. What a very cool point of view. I didn't think about that position in the questions that I prepare for you. So I was thinking about more about that you were more interested on maybe using robots in the military for different things, like for different services. But this point of uh, by using robotics, you can develop your problem solving skills. That's very cool. It's a very cool idea. So let's
And don't
let
get me wrong, we do. I mean, the Air Force and military
yeah,
in
yeah.
general use robotics everywhere.
Also, yeah,
Um,
yeah, yeah. Also, yeah.
so it just when we prepare engineers for the Air Force, we have to prepare well-rounded individuals. So we want them to be good at engineering, but they also have to be good leaders and be able to lead people as well.
Uh, yes, out of the topic and not in the questions and so on. So I like very much the books of leadership by Jocko Willing. I'm, I'm sure that you
Say that
already
again.
know. Jocko Willing
Mm-hmm.
is. Do you know the books of extreme ownership?
Oh yes, yes.
Of so yeah, so I like them very very much, and actually they are official books of our company, so everybody has to read those books because it's true. It teaches you about the skills of leadership, the basic
Mm-hmm.
skills of leadership, which are very very important in order to get a company. In your cases, in order to get a mission accomplished, and
Mm-hmm.
in our cases, in order to get a successful startup working.
Yeah. So I mean, that's one of the big differences at the Air Force Academy is these students are getting leadership training. They're learning about those other aspects of being a leader, but then also becoming engineers, becoming social scientists or chemistry chemists. So we are trying to build these leaders that are able to do technical things as well. And so that's I love teaching. I love teaching at the Air Force Academy. Unfortunately, I will be transitioning out of teaching. Um, so this summer, I'm getting out of the military and starting a career in my civilian life. So
Oh,
I'll
okay.
be wearing these clothes a lot more often. Um, but
Okay.
uh,
You're
but
killing
yeah,
all my questions. I was going to ask you. So, have you considered using those skills because now you are a senior leader in the military in the USA, U.S. Air Force, and
yeah.
then so have you considered applying all those skills that you have learned into the civilian life, like creating your own company or working as a leader in another company or going to the university to teach?
Yeah, so I'd love to continue in robotics, robotics research and robotics education. Um, I don't think teaching is in my future because mainly because I love spending all of my time doing research and playing with robots.
Uh-huh.
I enjoy teaching. I get a lot of value from it, but it's just I think we're not where I want to go in my path. So this summer I'm separating my. I'm going to spend a year consulting with the Air Force Academy, hopefully to do more, help them with their robotics education some more. So I'll be continuing kind of what I'm doing right now, just wearing this uniform. And then hopefully I'm looking to try to find a position doing robotics research, whether it's hands-on robotics research or more at a leadership level, kind of helping companies. Actually, I think it was February, you sent out an email asking for people to apply for a job building real robots in Spain. And I'm like, I talked to my wife and we're like, yeah, we would move to Spain and build robots. Unfortunately, I was still in the military, so I couldn't apply.
Oh, okay. It was last year.
Oh, it was last
That
year.
that position was last year and has been covered, of course.
Yeah.
And then this guy is the one that is in charge of our now. So it's of our remote real robot labs. So we have created, because I completely agree, as I mentioned to you, that the best experience to the students for learning robotics is with the real stuff, with the real. Then our academy is based on simulations. So because it's the easiest way to provide an experience with some robots. Gazebo simulations, so they have physics and all that, but at the end it's just a simulation. And then we wanted to provide a further step is to have real robot experience, and then we cannot send one robot to each one of the people, because I mean then we are broke. We will be broke of that, but we can have those robots here in Barcelona, and they connect from wherever they are, and they have some hours. So we have modified our curriculum, and at some point in time they are required to do this. And let me give you another, maybe if it's useful for you, okay? Not trying to say that I know better, but one idea that I found is that when they practice with the robot, so they do all this practice with a real robot, okay, very good. But then something extra to make them learn better is now you had to present. So you have to teach your project with that robot to the others. So they have to do a presentation, in our cases in YouTube. So they connected the way that we are connected right now. And then we broadcast into YouTube, and they present their project, and the audience, they're asking questions. And this is a way also to push the students to learn better the subject, because they have to defend, they have to think about how to answer the question, how to present very properly to the audience, so the audience can understand, and that makes them a little extra also.
Oh yeah, definitely. I mean, I think you know just as well as I do, Ricardo, teaching the subject makes you an expert at it.
Exactly.
That's the only way. Like I've learned more these last 3 years teaching than I did my entire university career.
Exactly. That's the point. Okay, so I don't know what to do now with the questions, and also, well, anyway, we have been here talking more than an hour. But let me see if I am missing any of the questions here. I have. Yes, so about the parts of the robots, the ROS, if we can use it, teach. Then also about the strategy of the robots, the role of the. Oh no, you didn't answer some part about this question, which is, so you are teaching those students at the Air Force for learning about robotics, and then what are they going to do after they are graduated there?
Yeah, so a lot of our students will go and actually become pilots. The Air Force Academy will send off most of their students as pilots. So a lot of our electrical and computer engineering students do fly aircraft. And so basically the idea is that they have an engineering mindset, whether it's robotics or power electronics. And so when they go and fly, they become experts of their aircraft. And so they can think about it a little bit differently than other people because they have an engineering background. And so a lot of the students will go fly. A lot of them go to grad school. A lot of our students will go to grad school and then join the military. And then again, just like when I joined, I was testing or developing or buying. A lot of our students will do that. And so unfortunately, we don't have a good way to say, okay, this student did research in robotics, let's go send them and do robotics in the Air Force. After they graduate, the Air Force kind of does what they need to do with them.
I see.
We can kind of we can send them to Carnegie Mellon to go get a master's in robotics, something along those lines, and then they can go do research with the Air Force and robotics. But it's hard to take a student and put them where we want them. So they're going to be doing all kinds of different engineering, but they're going to have a really good robotics background, and so hopefully they'll apply that one day.
Okay. Yeah, and you already mentioned the 3 positions that in your case, when you graduated, also for testing or for building some stuff or doing something else completely, the different positions that you can do. Okay, then. Okay, so then let's go for the final questions here. So I have seen in your LinkedIn profile that you are open to work. So which kind of work are you looking for?
Yeah, so I'd love to do robotics consulting. Right now, I have a very strong application level understanding of ROS. I am going to be doing a lot more learning on more of the kind of hard sciences of ROS. So I would love to start contributing to the ROS infrastructure. And so that's what I'm going to start working on, developing my skills and expertise towards. And so, yeah, I need to get my name hooked up onto your email list, or not the email list, but what is the
Yes, the
list
ROS Developers for Hiring list.
Yes, exactly.
Yes. So there is a list, just for the audience who doesn't know. So we have created a list of ROS developers that are able to be hired, because we received many requests from companies or individuals that they need to do a specific project on ROS and they need some support. It's most of the times it's just for a specific project. It's not for hiring for a full-time position, but most of the times they are hiring, we are doing this, our own project, but of course we lack knowledge, we don't know everything, and we cannot hire a complete ROS engineer for life and for just because of that. But we would like to have support hours, like for this project, and let's say you get 40 hours for support, so you can review that we are doing correctly, or if provide us suggestions, or even create some code for us so we can move faster. Then in that case, we have created this list of ROS developers that are for hiring. So any ROS developer out there that is interested, they can go to the list and then create the profile. It's completely free. It's also free for the companies to browse and contact the person. We don't send the details to the companies, so you will have to, once you establish the contact with a company that requests your services, then you will manage yourself. So it's up to you. But then it's open there, and yeah, that's the list of ROS developers for hiring. So you want to put your profile over there?
Yep, I'll get my profile on there probably this week.
Okay. And then, and then let's talk at the ROSCon.
Yes, exactly.
Let's talk at the ROSCon, and then we'll see what we can do. Let's talk at the ROSCon. Okay, then yes. So I think that's all for today. Thank you very much, Steve. It's been an awesome conversation. It's already 1 hour and 10 minutes that we've been talking. Right?
feels like 15 minutes.
Yeah, exactly. It was very, very interesting and very quick, and I had a lot of curiosity about how robotics works in the military, and then you put some light in there.
No, thank you for this opportunity, Ricardo. I really appreciate it. I hope the community now knows a little bit more about the United States Air Force and how we can utilize ROS and how we are using ROS. So I appreciate your time, and let me know if you need anything.
Okay, thank you very much, Steve. And now for all the audience over there, so this is all for today. Remember that we like very much that you give us some feedback. Please put in the comments, if you are watching the video, put your comments on the video. What do you think? Also, suggest us some other things that you would like to have. We have received some suggestions and we are taking action to move into that direction. But any comment, if you don't like it, also put don't like, but please tell us why you don't like. Okay, so that's it for today. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.